In a research facility, investigators are researching 5 monkeys. So they build a big glass room, they put 5 monkeys in that glass room, and they also put a banana in that room, on a shelf somewhere. So you can imagine what happens. There are 5 monkeys, 1 banana. What happens? They go to the banana. But the moment the first monkey touches the banana, all the monkeys are sprayed with ice cold water. They are soaking wet, ice cold. So they draw back and they try again. They are sprayed again with ice cold water, and again and again. Until the moment no monkey dares to touch that banana again. Then the researchers take 1 monkey out. They put 1 new monkey in the cage. 1 dry monkey, 4 wet monkeys. The dry monkey sees the banana. He thinks, that's mine. They do not touch it, it's mine. But the moment that monkey wants to go to the banana, the 4 other monkeys restrain him. They just pull him back. You are not going to touch that banana because it's getting us very wet. We are soaking and you are dry, don't do it. Then they take another monkey out. Same thing happens. Take another monkey out. Until the moment there are 5 dry monkeys in the cage and nobody touches the banana. Welcome to my talk about Continuous Delivery 3.0. And what this story has to do with continuous delivery, I hope that I will make that clear in the rest of my story. My name is Rene. I work at Xspirit in the Netherlands and I work as a DevOps consultant. I help companies to transform digitally into their journey onto the DevOps train. And this story is all about how we can do that. And this is about Continuous Delivery 3.0. So, because I'm a consultant, I always start by taking a baseline. Just measuring what is there, what can I expect from my customer. And because it's a little bit too much to do an interview with all of you in this audience, I have a different experiment. So I would like you to stand up. And then I'm going to count to 3. And at the count of 3, I want to ask you if you want to clap your hands 5 times. And the noise that you make with that clapping, it's all up to you. It's the baseline. So if you clap loud or soft, that's all up to you. So I will count to 3, and then you clap 5 times, and then we will continue, and it will all become clear later on. So 1, 2, 3. Awesome. So applause at my first slide. That's awesome. And now you can sit down. I will continue. Thank you very much. So our market is changing rapidly from a capital expense market into an operational expense market. And I think the best example that I can give on capital expense versus operational expense is my personal situation. Because recently, in the last few years, I didn't buy any CDs anymore. I listened to Spotify. I didn't buy any DVDs anymore with series or films. I watch Netflix. I don't buy any books. I read my books or I listen to my books in a subscription model on Audible or Storytel. So my personal situation is moving from a capital expense where I own the stuff into an operational expense where I only pay for the things that I actually want to use. And the same thing happens within companies. Because companies are also not investing anymore into the big capital. And especially the companies that are making the difference currently, that are really digital disrupting this whole area, they are making very good use of this because they don't need to make a 100 million or 200 million investments in all kinds of capital. They can just start with spinning up some servers in the cloud and they can compete with those big boys. And we see these examples all over the place. So for example, Taxify and Uber and Airbnb, those are the perfect examples of companies that really know how to use operational expense instead of capital expense. So for example, Uber, which is one of the biggest taxi companies in the world, they don't own any taxi. They don't have any capital investment in taxis. Airbnb is one of the biggest hotel chains in the world, but they don't have any rooms or hotels or any other venues. So that is a big difference. And what is the big difference between those newer companies that don't have these capital expenses and these operational expenses, or the other way around, so those older companies? The big difference is that those new non-capital expense companies, they see IT as their business. They build their business around an IT system. So instead of the older companies that build their IT around the business they are running, which the business is their core competency, those newer disruptors, they really see IT as their core competency. They don't see IT as a cost center, which means that it can rapidly change, and they do a lot of investment in IT to become better and better. Because when you look at it, every company at this moment is already or is becoming a software IT company. If you pull the plug in a bank, all the systems are down. If you fire all the bankers in a bank, probably the bank will run for another few days. That is the big difference. So is it the bank or is it an IT company? So those older companies, they already know that this is happening for a long time. Because when I looked it up, Agile has been around for already 18 years. And Agile was the process that promised us to say, we can, instead of delivering software within a matter of maybe months or years, just like we heard in the keynote this morning, Agile promised us that we can deliver our software in a matter of weeks, in a sprint, 2 weeks or 3 weeks. And that is the promise that Agile made. And Agile was going to make the business faster. But instead, Agile and Scrum, they solved the problem of developing software very fast. But they didn't really solve the problem of delivering software very fast. So the bottleneck shifted from not being able to develop our software in a timely fashion, it shifted towards not being able to deliver our software in a timely fashion, which results in big shelves with features that are not being delivered to customers and do not add or gain us any value. So we need to make that transition, and that is currently in all the year plans of the companies, continuous delivery. We need to go towards continuous delivery, which is, in my opinion, a subset of DevOps, because DevOps is a little bit more broad, but continuous delivery is all about delivering tools and techniques for the rapid, reliable and continuous development and delivery of software. Being able as a company to develop our software so that it is high quality, continuously, and that we can ship it. Continuous more or less implicates that we want to do that continuously, 100 times a day or 200 times a day or 1 time a day. But in my opinion, continuous delivery is about being able to ship on demand. If I want to ship, I can ship. Because my software is always in a stable state, it's always been tested, it's always good enough to go to the customer. On demand is something different and 100 times a day, because that's not a goal, in my opinion. So what happens is those companies that see that happening, they have a lot of software, they have a lot of big systems, they have a lot of procedures and a lot of tools in place, and they want to just make that happen, make it better, make it faster. So they are going to optimize their processes. And what happens in that is that they will hit some blockades. So they are trying to push that big monolith that they have, or those big procedures that they have. They want to try to make that better, but in the end, they will probably result in something like this, where it just doesn't fit. You cannot go with a big truck into a small, narrow tunnel. That is what we are seeing happening. But now it's time for my second measurement. So I want you to stand up again. And, well, you know the trick, so I'm going to count to 3 again, but at this time I want you to make a bit more noise. So, 1, 2, 3. Very good, very good. Awesome, thank you. Sit. So there are some people that are thinking disruptive, and that's what I like. But the majority of the audience was clapping louder. And that is exactly what is, in my opinion, Continuous Delivery 3.0 is all about. Because Continuous Delivery 3.0 is not about optimizing what you already do, which will eventually squeeze you in a tunnel. It is about rethinking what you should do. So that guy that was screaming, or lady, I didn't hear correctly, That one is thinking, because I asked for more noise. I didn't ask you to clap louder. But because we did, because we are humans and we are programmed in a certain way, we are very much willing to do the same thing that we already did. So the first time I asked you to clap 5 times. Second time, most of the people clapped louder 5 times. But how often can you clap louder? You should do something different in order to make real noise. So the thing that you need to do, because the same thing happens within companies, you should ask always, when you want to move a company into continuous delivery, the things that we currently do, why do we do this? And do the old constraints that we have in place still apply? For example, we need to share a test server, so we need to wait for the other team to complete. That is an old thought, because currently with cloud infrastructure, we don't need a shared server, because a new server is spun up in a matter of minutes. You don't have to wait for weeks. And you can think of many, many examples that probably also in your own companies are there, that solved a problem that was there a long time ago. But if you ask the question and challenge the status quo and you ask, why do we do this? Why was this a good idea back then? And is this still relevant? Then you will probably notice that a lot of things that we are doing currently and that we want to do and want to optimize maybe are not even relevant in our situation anymore. We need to change our thinking. Because essentially it's the same thing as the monkeys in the cage. We learned that behavior. We are not going to touch that banana. We are not going to change this procedure. This is how we work. This is how this company operates. And the same thing happens. But if you dare to touch the banana, probably nothing happens. You won't get sprayed. That is, I think, the key message of my presentation here is that if you want to move into a situation where you really, really want to make speed, you really need to reconsider the things that you are doing and try not to optimize the things you're doing, but try to rethink how can you do it differently. And to make it a bit more concrete, I have a few examples for you. One of the things that I hear of often is we spend too much time on manual tests. So we cannot go to continuous delivery because we have this big pile of manual testing that we need to do. And that needs to be done every time that we release. So in order, if we want to release every day, we need to run our manual tests every day. That is going to be a hard situation. So many companies, what they will do is they say, okay, then of course we need to automate our tests. Makes sense, doesn't it? But then they will choose a UI testing tool, for example. So they use Selenium or I don't know what kind of tool you want to use for testing manually. And they are going to automate their manual tests, which is fine because it gives you a lot of speed. But on the other hand, you will hit the bar very soon because manual testing automated, like UI testing, those things are very, very hard to create, very hard to maintain, and very hard to keep stable. And in the end, it won't gain you the speed of really, really fast deploying multiple times a day. So in order to change that, you can maybe say, maybe we should not automate our manual testing, but we should shift our focus into maybe writing some more unit tests, refactor our architecture so that we can test our backend so that we don't need a UI. And then maybe at the top of a pyramid, if we use the agile test pyramid approach, only do a bit of exploratory testing and manual testing in the end and reduce the number of manual tests even more. So that's a different approach. Another approach is to think completely different about automated testing and to say, well, we currently have our test environment, we currently have our acceptance environment, and we deploy it to there, and then we need to generate load, and we need to generate data sets, and we need to generate a lot of things in order to resemble production. Because yeah, production is totally different. There is no place like production. Our great inspirational Microsoft leader Brian Harry once said, there is no place like production. So if there is no place like production, why not test in production? Because that's the only relevant situation that you will ever encounter. But in order to test in production, you need to do a lot of things. You cannot just test in production. You need to do, for example, chaos engineering, where you think about hypotheses, or to think about what can happen in my production system, and how can I measure it, how can I monitor it, and how can I make it resilient. Or you can do something like feature toggling. Who uses feature toggles? Okay, awesome. For the ones that don't, feature toggles are essentially a big if statement in your code, which says, if this thing is switched on, I'm going to execute this code path. If it's off, I'm going to execute that code path. And you can switch it on for maybe certain groups, or for certain IP numbers, or IP ranges, or maybe trusted users. And then you can say, okay, I'm going to use my production systems, only the functionality that I'm wanting to test, it's just not switched on. It's hidden from my end users, but it's there. And if I want to switch it on for this set of users, I can already switch it on. Or I can maybe just use the functionality but not make it production, use production data, for example, or write a separate mirror table. So you can do a lot of extra things when modifying your code with feature toggles, and that allows you to do a lot of things like, for example, testing in production. Just run through all the steps. Another argument that I hear a lot is we cannot continuous delivery because we are never ready. Our teams are just never ready. So if this team is ready, then this team is not ready. So we have to wait, and we have to do a stabilization period, and then we have to merge, and we have to test, and all that stuff. Feature toggles is, for example, one of the things that you can do in order to solve this, where you can say, I have a feature toggle and it's on, and when it's done, when everything is done, only then I'm going to switch the feature toggle, and then it's in production, but it's already there. But essentially what I'm saying is, you should make release management a functional practice. You should shift your thinking many, many times, and I think that counts for here as well, is that when you do a release, when people talk about a release is a deployment, and it's automatically the exposure of the functionality. So deployment and functionality is the same thing. But if you separate the two, and if you say, I have a deployment, that's a technical practice. It's just running through a certain amount of steps and scripts, and I'm moving towards my production systems. That's the deployment part. And when it's there, all the feature toggles are off. Nobody can actually use it. The moment my product manager says, now I'm ready for it, now is this big marketing launch, now is the date that we want to really expose our functionality, that is the functional release. That's where I switch on the feature toggles. That's where I expose my functionality. And by separating those two, you can really make a difference. Because that's how the big events of Microsoft, for example, run. They do not deploy the moment for the big event. They deploy weeks before. And they only expose the functionality at the moment it counts. Then we have this one, who recognizes this one. Well, we cannot do it because we have a lot of security and compliancy checks that we need to do. And security and compliancy is traditionally also people that are in your organization that want to check a lot of rules. So I have some rules that I encountered during my security and compliancy trip at a bank, where it must display this and it must display that, and I need to implement this rule and that rule. And it is always a manual check. It's always a manual validation if it already happens. And what I see is that people use the classic security model. Is that it seems secure at a certain point in time, but the moment, like when time goes on, the security declines and declines and declines. And only when an audit is coming up, people are very fast making up their documentation and checking some stuff. This is not good, but this is maybe a bit feasible when you release once every half a year or once a year. Then you can maybe manually check your systems. But when you release every day, or 2 times a day, or 20 times a day, then this is not feasible. You need to rethink the way how you will check your security. And in order to do that, you need to make your security shift left. You need to make them part of your development team. So what we see now is that development teams, they don't have the security practices. They don't have people in their teams that know security. So the developers know security a bit, but not in a way the security officers know security. And the security officers, they know security, but they don't know development, so they don't know what to check. So that's where the DevOps part comes in. If you bring developers and testers into a team to make it a bit faster, and if you bring operations in that same team to make the operations part of the cycle as well, you should also bring in security. Maybe not full time, maybe 2 days a week, I don't know. But they need to be part of the cycle so they can help and educate your developers to make your code more secure. And you can do very, very simple things like automation. For example, there is a tool called CredScan. You can run that in your build pipelines that checks all your credentials in your Git repo. So you don't need to check manually if everything is still secure and passwords are rotated. You can just run scripts to see if there is no any security password in your code. Is there any vulnerability? There are checks for that. There are tools for that, like Black Duck, White Source, Veracode. There is a lot of things available on the marketplace. There is tools available for checking your infrastructure, like the DevOps toolkits from Azure. There is a lot of available for Amazon, CloudTrails, who is accessing what. So there is a lot of tools available that can help you making your products more secure. And you should integrate them in your pipeline, just as you integrate your unit tests or everything else. Another one is we cannot afford downtime, because when we deploy, our system is maybe out of the air for a few minutes, for a few hours. So we need to have that window where we deploy, maybe during the weekends. So in order to do that, there are all kinds of practices that you can do, like, for example, canary releasing. Canary release comes from the mining. So what the people in the mines in the early days, what they did is, in order to see if there were any toxic fumes within the mine, they took a canary with them. So when they walked into the mine and they were there for 5 minutes, if there were any toxic fumes, the poor canary would die. But the good part of that is that they had about 5 minutes to leave the mine as soon as possible. And the same thing you can do with your deployment of your code, because you can deploy it directly to production, to all your users, and then find out that there is a bug in your code and nobody can, maybe for example, log in or check out the shopping cart. But if you deploy it to a small group of users on a maybe different set of servers, and that small set of users is going to just use the product as they are used to. And if those users are trusted users, they can already work with the product. And after a few hours, you can see, oh well, there is no errors, you have your monitoring in place, everything is working fine. Now I'm going to roll out to my next set of servers, or maybe to a production situation. And you can build in those rings, as we also call them, as many as you like. And I don't know who is in the Windows 10 Insider program. I don't know if there are any Windows users here. But yeah, that's exactly what this also is. So you are beta testing your Windows. Because you are a trusted user, you signed up for the program, and if something's wrong, they say, yeah, well, it's better. We said that to you. So that's what you can also introduce by just adding an extra set of servers. And dark launch is built up on that practice where you say, I have this functionality in my code. For example, I have this feature that calls an API, and I want to know if it stays stable. If you don't expose that functionality, but you always call the API no matter what, but you don't let any dependencies in your code, you can still see if your API works, if it's responsive, if it's performant, but your users are not using the functionality as they would do in the future. So all those kinds of practices will really help you in investigating if your product is stable. Then another one is we have too many teams and dependencies. So What I see a lot is that if there are multiple teams working on the same code base together, then what many companies will do, they will introduce all kinds of complex branching strategies to make that a bit easier. Because we want to isolate it. We want to make sure that if I am developing something, that my co-workers do not touch it or are not interfered by it, and if I deploy it, that it is not crashing. So there is a branch created, and that branch is being deployed, and all that, etc., etc. And that's all nice and good, but it's very, very hard to make that merge. You will keep that isolation. You want to merge as soon as possible. You will want to work from one branch, everybody the same code. So instead, maybe we should rethink our architecture. If we see that we need a lot of branching, that means that we have a lot of dependencies between the many, many people and many, many teams in our organization. So for example, we can make use of packages. So instead of building all in the same code base, we should maybe say, let's build an autonomous package with an API and an interface and a contract. And we as a team are responsible for creating and maintaining the packages, and also responsible for keeping it backward compatible. And we are releasing new versions of the package, so that people are not relying on us to be out, so that our work is complete, but they can just use the stuff. Same goes if you take it a little bit further into the microservices architectures. They say instead of building that big application that is released as one monolith, we are building small microservices, and teams build and run that microservice. And if the microservice itself changes, it doesn't really matter as long as the contract stays the same. Because as another team, I don't want to know, I don't need to know what happens inside that microservice. So if you see a lot of dependencies, you should really consider okay, how can I split up my architecture so that it keeps, so everything runs autonomously. So if you have this flexible architecture with a lot of microservices, for example, you might also want to see that you need a flexible and fast deployment platform. Because you can imagine that if you have a microservice and you have 20 microservices or you have 30 microservices, that doesn't work in the traditional sense where you deploy it to a web server, for example. It's very, very hard, because if something changes, the web server, maybe something is rebooted, and you don't want to have 30 servers for running a small, tiny bit of code. So if you are going to move towards maybe microservices architectures where you run those smaller autonomous services, you also might want to need a different platform. And one of the things you can consider is, for example, platform as a service. You can run your stuff as a web application hosted by the platform like Azure or Amazon. You can also run it serverless like Lambda or Azure Functions, where you just deploy your code and you don't care about where it runs and how it scales. The platform takes care of that. But another thing is that you can also use, for example, Docker, where you can create immutable containers and you deploy your application into a Docker container. So who works with Docker? Okay. And who have never seen or touched Docker? Okay, well, that is good. So the beauty of Docker is, I think, that it really changes the way that we can develop and deploy our applications. Because instead of having to have a test environment that resembles production, where we have to deploy our stuff, where we have to do configuration, where the configuration changes, and where we need to know a lot of the inner workings of our application, we can just create an immutable versioned container, and that container is more or less, if it runs on my machine on my local Docker, then it probably also works on the cluster. Of course, it depends a little bit on how you build the code. If you have an if statement that on my local machine it goes to another container, and on the production it goes to some web service on the internet, of course the behavior changes. But if you essentially look at the inner workings of the container, if it works, it works. You don't need to know the inner workings of the container. And this also helps a lot in how we deploy our application. So if you see how we deploy our traditional applications, we have our source control and we have our build pipeline and our release pipeline where we extract the source from source control, where we build our binaries and then we deploy it to our test environments and maybe to our acceptance environments. We run some tests and then we just go ahead if it all works, and then eventually we move to production. The steps that we execute in this pipeline, it's more or less the same in every environment. In every environment that we add, we need to reiterate on that. When we work with containers, this deployment model is a lot simpler. And in terms of continuous delivery, it's really, really easy because we have our source in source control. It's not only the application source, but it's also our infrastructure source. It defines the platform, the container, and the application within the container. So we build it, we create the container, we move the container towards a registry somewhere on the internet or on-prem where everybody can access that container, that immutable package, and then they can just pull it from that registry on their machine or onto their cluster, and they just hit run, and it just runs. So instead of having all these steps, the only thing that we need to do is build, push to a registry, and pull from a registry in order to make it work. So I think that really, really enables developers to, and operations people to closer work together in running a platform. So as a wrap-up, small. Keep asking if the same constraints still apply. So if you want to move towards continuous delivery, or you already are moving to continuous delivery and you want to make it better, faster, and cheaper again, keep asking if the constraints that you apply to your situation, the things that are restraining you from extra speed, do they still apply? Are these rules still applicable, or are those rules from the past? And are we just saying like the monkeys, yeah, that's how it works here, we cannot touch it? And really, really challenge that status quo, because you will see that if you challenge enough, you will see that a lot of rules that are in place are not relevant anymore. I've been there a lot of times. So instead of optimizing the things that you already do, rethink. Try to make it different. And then try to shift left as much as possible. Shift your tests left, shift your operations people to the left, and shift your security people to the left. So to make them really part of that DevOps team, so that you have all the expertise to really gain that speed. Do not only think about your application, think about your infrastructure, think about your monitoring as well, and think about your security. And as last, think immutable. So don't build your infrastructures by hand and deploy your applications, but build your infrastructures from code as well. Make it immutable. Make it at the press of a button so that you can build up everything that you want. So with that, I would like you to ask one more time to see if you've learned something. So can you please stand up again? And then I'm going to count to 3 again, and I want you to make more noise than the previous 2 times. And then you can ask for some questions. 1, 2, 3. Thank you very much. Any questions? I have some Slidos here. Join@slido.com. No questions here? Any questions from the audience? Are you all asleep? Yeah.
How do you connect data to the pipeline in your next workflow?
Data. Yeah, data is always a tricky topic, but I think that data is of course a thing that needs some things. But if you use a traditional SQL Server database, for example, one thing that you can do is that you can deploy your database in multiple steps. So instead of running your SQL scripts as part of your pipeline together with your code, which, well, with the simple changes is not really hard, but for the, like dropping a column or adding a null constraint or something, that might change. What you can do is you can run multiple times. So for example, you can first change your binaries so that it can work with multiple versions of your data model. So for example, you can introduce a new table that resembles the previous table, but only where you dropped a column or you changed a column. So you first deploy a new table, then you deploy new binaries that can handle both of the things, and you have, for example, something in the backend that just moves your data to the second table. And then when everything is moved and everything is changed, you can add a new script to say, okay, now I'm going to drop that table or I'm going to move the constraint. So data is something that you should really play nicely. There are some tools for that as well, but I think when you really have big chunks of data, then the tools will probably get you some downtime because it just locks your database. So you should multi-stage where you just make sure that you can support both things of the thing. Yeah, it's clear?
Друзья, еще вопросы? Если есть, то вы можете их задать, потому что у нас еще есть 5 минуточек. Все, вижу, что вопросов нет. Аплодисменты для наших спикеров. Спасибо большое.